quick thing I had to deal with. So this is going to be a slightly different talk to some of the other ones that we've had, which have been very much about technologies and tools and all the rest of it. This is a story of a journey, and this is the story of how my previous employer, as I shall explain in a moment, we took a fairly messy application with some fairly horrible release practices, such as you could even claim that they were practices, and over the course of around 12 months, via small incremental improvements, we managed to turn it into something which was still a horrible application, but at least we could deploy it consistently, and at least when we realised that it had all gone horribly wrong, we could roll back, we could get a site operational again in a matter of a few minutes, compared to having downtimes of several hours whilst we worked out why on earth the upgrade had completely destroyed the database performance or something like that. So, who am I? I'm Stu Teasdale. I've talked at a few of these conferences over the years. I get lumbered into these things partially because I know the wrong people, and you know, they keep on asking me to come back, so I need to do worse at my talks. My background is systems administration. I've been doing sysadmin in various places for about 15 years, and first of all with universities and then out into the commercial sector. So I've seen pretty much the worst of both, and the challenges that come with both are quite different, yet somehow seem to converge in the same sort of place. Now, the particular case I want to talk about today is for this thing. You may wonder what on earth that is. It has a very swirly logo, which actually spells the name, and it took me about 3 months after I joined the company to realise that swirly logo says Loop, and the product is called Loop. This is just how dim I am. So what does Loop do? So Loop consists of a few separate components. There is an energy monitor that clips over the cable of your electric meter and via induction measures the current passing through. Now that sounds vaguely interesting, but the thing is that from that you can infer how much electricity somebody is using, so you can essentially read their meter from remote without having to spend a fortune on a smart meter. So it has that sort of interesting feature. However, it's also running off battery and trying to steal a bit of power that's going through the cable as it goes. So we need a second component, which is the blue bit, which plugs into your router, and it communicates wirelessly back to the device and gets a reading every 15 minutes or so and ships it off into the cloud, or our server, as it was also known. So, having collected this data, we needed to do things with it, and this sort of leads to some of the unusual challenges of the architecture of the platform, which was that each one of those bits of data, which could come through typically at least every 15 minutes, but if people were actually using electricity, we could steal some of it, which meant we could ship a message more often, up to around about every 8 seconds, is tiny. It's just a few bytes. Basically, it's a number. Amount of electricity used, basically it's just a rolling counter of electricity used. But we've got quite a lot of devices, they're all connecting back to a server, and they're all firing these messages every 8 seconds to 15 minutes. So there's lots of concurrent connections, potentially, and there's lots of little updates going on, which causes a few problems, but it also turns out that people don't look at this data very often. So the web application that then presents it all gets, on average, 1 user. Just one. When we introduced some additional monitoring onto the platform, we realised that the additional monitoring was generating 5 times more load on the system than the user base was. So we weren't too worried about the web application, which is just as well when I come on to what was wrong. That wasn't our system. But it's probably quite a reasonable representation of what the code was like. What it doesn't truly represent is the fact that there are actually 3 of these. We had a front end, which was written in PHP, built on top of Drupal of all things. Drupal is an excellent content management system and entirely unsuitable for mass use websites where you have a large number of people coming in and a small number of people actually generating a large number of people wanting to generate content, essentially, and therefore using Drupal's own inbuilt user management for 1,000 people is foolish. That's how we implemented it. We had this talked via the database to a Node.js backend. In some ways, Node was a very good fit for this because Node is absolutely brilliant if your application doesn't do anything. And for large swathes of the time, our application didn't do anything. It was just sat there waiting for the next arrival of a piece of data and doing that across a large number of devices. So for all its failings, it wasn't a bad technological fit, but it was communicating with the front end via the database. And the front end owned the schema, which meant that the back end we couldn't easily change the schema on the back end. This would have been fine if we had one dev team. We actually had outsourced production of the front end to a separate web hosting company, a web design company, which is why they'd chosen to do it in Drupal in the first place. And we had the back end, which was being done in-house, and we also had then a third development team working on the firmware side on the device. So we had a certain amount of fragmentation, nearly that much fragmentation, in fact, although without the nice green screen in the middle. When we first did this, I say we, at this point I didn't work for them, otherwise, so I'm going to claim no responsibility at all. I want to make it very clear I had nothing to do with this. The project had got to the point where it was about 8 weeks from launch, and the company had booked themselves into the Ideal Home exhibition with a big stand to launch the product. They had a front end, they had a back end, but the back end didn't work at all. Not even slightly, and it refused to talk to the devices in any way, shape or form. What followed was basically 2 months worth of frenzied activity where the Node.js stuff came to life, having been originally tried to be done in Java, and it turns out you need Java developers to write Java. You need PHP developers to write PHP, but they appear to be easier to find for some reason. So rapid technology change, 6 weeks worth of frenzied activity, a thing that worked. You can imagine, given the fact it was basically the work of one engineer, what this piece of code looked like. Those of you that know JavaScript, we had basically had a single block, single top-level object with 1,700 lines worth of JavaScript in it, and the structure went sort of like that inside. Had a few minor issues. And because of the way that this had been done, we had a development environment which had been hastily put into service as a production-ish environment where people that worked for the company had devices that actually connected to it, and we were treating it like a production service with a few tens of devices on to get there. But this meant we no longer had a development environment. And we had a production environment, and that didn't really look anything like the mini production environment. And there was nowhere left to run anything else. The dev environment itself had been rapidly shoved into AWS in the style of, oh look, that's a way of getting a server really easily. And the main production platform was stuck onto a co-located machine, which had been primarily selected, as far as I could tell, because we knew some people that knew where to find one of those. Again, the problem with a small company, expertise was not where it needed to be. Unfortunate compromises were decided on. So we've got now local development happening on local workstations, which are running some random version of Fedora. We've got a dev environment, which was hand-built, running RHEL 6, which had been chosen because the production box that they had leased came installed with RHEL. The entire selection for that had been made because that's what the third party had provided to us. And it wasn't what we were developing on. So I hope I'm building up an image here, and it looks a little like that. At about this time, there was a growing realization this wasn't going to work in the medium to long term, or the short term. So alongside getting some additional hiring in, so they managed to hire a good dev lead, there was an open admission that we needed to be better. And initially, given where the new expertise came from, this again is a few months before I joined the company, the first stage was, well, let's at least consistently build and test this thing. rather than trying to cram it onto this dev-ish, production-ish environment, have it break for a few days, beat it with a stick, and hope that you can get something that then breaks in the same way when you put it into production, but it's okay because you've already learned how to fix it. The other thing that we started to do off the back of getting some CI in, so that we were actually continuously breaking it and learning how to fix it, is that it also meant that we could start to accumulate that collected knowledge about how to take this hand-built system and put it somewhere into a set of scripts which Jenkins can call. And we can test those. So we're starting to build up now. So just checking how I'm doing for time. Oh, I haven't actually started yet. That's kind of alarming. It's only just 10 o'clock. That we needed to test all the things. And realization that we needed to test the code better, because the code that was coming through we had no way of knowing when it was going to hit problems when we actually started connecting real devices to it. We had no real grasp of whether there were any scaling issues, whether the thing even worked, and all we had was an ad hoc way of looking at the website in whatever browser somebody happened to have on their desktop to see if it was working. And we're starting to build something that looks a bit like an infrastructure rather than a random server. So we'd quite like to test that as well, because I like to sleep at night. Although I hadn't joined by that point and I was still sleeping fine. And we now need somewhere consistent that we can do this QA. So can we start to use these tools that we're getting to build another environment? And this time build an environment that starts to look a little bit like where we want things to end up, but only a little bit like. So what we're trying to do here, essentially, is take this ad hoc collection and turn it into a pipeline. Where I work now, unfortunately, I came and I started talking about pipelines and all the rest of it, and I now work for a company that does genomic analysis. Turns out pipeline doesn't mean what I think it means anymore, because there's special uses of the word. But in this case, this comes straight out of the continuous integration world. The idea is that we want to check something in over here, and eventually it comes out over there as a production system. But we didn't really have any of the bits we needed to do that. We had one advantage, which was that in order to have somewhere to run this preview, production, but not very environment, we'd gone into AWS and we'd put a random machine in AWS, which at least gave us a start point. And we'd got RAL, so, well, let's make a base RAL machine. Let's snapshot it. That would be nice and easy. That means we can always get back to where we started from. At least we know now that we've got a consistent start place to go from, which is a good place to go. So then let's spin that up every time, and we'll call it act test 02, oddly. 01 had been ad hoc built and never really worked properly, so it's a good job we never have any indexing problems in this industry. We've got the beginnings of something that might be reproducible. I can now deploy the same machine repeatedly with the same name. We'll come back to that later, that's fine, don't worry about that. But now what I can do is I can deploy my software onto it, and then I can throw it away, having decided whether it was a good idea to do that or not. But then, of course, I can deploy my software onto it again. So we're starting to build up this concept that what we can do is reproducible. And the other thing we can now do is take that and say, well, actually, what we could really do with is, rather than just shoving our code onto dev, preview, production-ish as our way of testing whether the live release is going to work, why don't we build a staging environment? I've got an idea here. And why don't we fill it with anonymized data so that other people can look at it without us getting a big fine from the Information Commissioner? This may also be a good idea. And so from here, we've got the building blocks. Remember, we've still got dev and production lurking over here that don't look anything like each other and don't really quite look like what we're building, but we're slowly edging towards building up these components that allow us to at least be consistent about the early part of the testing. But what we've gone and done here is we've really just reproduced a standard physical architecture, but we're paying twice as much for it because we're doing it in AWS. And we're not doing any of the clever stuff. We're just about getting to the point where we'll do an acceptance test run, and if there isn't another one to be kicked off immediately, then, well, maybe we'll shut the machine down, and certainly at the end of the day, we'll run a script at, say, 9 o'clock in the evening, which shuts all the machines down, so we're only spending whatever 2/3 times 2 is. That's too much maths for this time. One and a third times as much as we would be paying to do it on physical. Unless, of course, you're paying a fortune for your physical, in which case you probably want to find a new hosting provider. And our production system is still on this physical tin anyway, so a lot of the stuff we're doing here is quite good from an operational perspective in that we're testing, but it isn't really telling us anything about how the code's really going to perform when it gets to our physical box, which is sat over somewhere else and has still got the name that it was given by the hosting provider when they put the base install on, so it's called something like IS5730, which makes no sense to anyone. So, why don't we get rid of it? Why don't we ditch our production system? I've always found that systems administration is much, much easier if you don't have a production system. I've been pushing hard for this everywhere I work. It generates massive cost savings for the business, and it ensures that my phone doesn't go off very often. There are some other people that seem to think that this isn't a good long-term strategy, but, you know, what do they know? So we've got, going back to this physical box that was built in a hurry, every time we deployed onto it, we weren't quite sure what was going to happen, not because we weren't testing everything that we could possibly test further down the tree, but because nobody really knew what software was installed on it. The person that had built the box in a hurry in order to make our crazy release deadline had left. His collected knowledge had been sparsely passed on to a team which consisted of one very good senior engineer and two very junior good engineers, and nobody really in between. And this third-party group of people that were busy hacking away writing PHP, putting it into their Subversion repository, which we would then have to pull into a separate Git repository, which we would then run a script which merged it back into another Git repository, which hopefully, if every script that did the pulling round meant it ended up in the right place when we ran the production install and it didn't explode. Sometimes it did explode. Also, nobody really knew how the MySQL was configured. And the biggest problem we probably faced at that point is nobody really had any confidence that we could reboot the box. This is about the point at which I joined the company, and my first reaction was, what does your production system look like? And my second reaction was, ow. My third reaction was to start heading towards the door before they blocked it. I foolishly stayed around for another year, and we did some other stuff, which we'll come on to in a moment. And we were coming to the end of the first year's worth of contract anyway, so it was a good time to review what we had. And at the very least, we were going to have to rebuild production, which, unfortunately, since we actually had launched, meant migrating it somewhere. And wouldn't it be nice now, when we did migrate it somewhere, that we actually built this new production that we would migrate to in the same way as we built everything else? Or at the very least in a consistent, reproducible way, which, you know, has been a popular thing for quite a while now. And wouldn't it be nice if we could capture all of those random dependencies and have some confidence that we knew the things in our stack that we actually needed, and we could get rid of the things from our stack that we didn't actually need, for a whole variety of reasons to do with, well, why have software we don't want? I'm sure we had more attack vectors via the stuff that we didn't even know we had installed than we did via our own PHP code, which, given our PHP code, is quite a shocking situation to be in. So let's try and capture all that, and let's try and build as much of this system, right from over here where the developers are busy beavering away, as we can in a consistent way, carries all the way through the stack. And you'll notice none of this is talking about technology beyond being rude about it. This is all about methods, processes, and approaches more than it is about individual technologies. And on that line, we came up with an idea. I'm sure many of you have heard of blue-green deployments. They are generally quite a nice way, if you can afford to buy lots of hardware, of ensuring that when you deploy a new system, you'll have an old one that you can fall back to. This often goes hand in hand with having multiple data centers and switching between data centers, so you also have a disaster recovery failover strategy and such like. And so our first plan was, let's do blue-green. Probably no point in going on too much about the nature of blue-green deployments. I'm sure you're all reasonably familiar with both their pros and cons. The biggest thing is you need to stick something in the way in the front so you can switch from blue to green and green to blue, and you also need to think about what happens with your data synchronization between the two. I have seen people that have drawn this diagram and then they've just put a single database over on this right-hand side with arrows going back in, which sort of seems to defeat the whole object of blue-green deployment and ensure that no matter what you do, you still can't make any schema changes. I prefer to keep the boxes separate, if slightly out of alignment. But hang on a minute, that's a really old way of thinking. That's what you do if you've bought lots of physical machines. That's how you justify buying twice as much hardware to the accounts department. Perhaps we can do something a bit different here. After all, we are in the age of the cloud. And these people were about to end up in a cloud briefly before plummeting off the end of an alpine ridge. Do not take that analogy too far. Why do we need to care that we've gone from having one special environment, our production environment, to having two special environments, two different coloured production environments? What's special about them at all? Why should we ever care about reusing the name? The only really important thing here is that we've got a concept of something which is our current production environment. We have something concrete that we can point the users to, and that user, as we've established earlier, we only have one of them at any one time, can see the website. And all those thousands of devices that are connecting back into the back end can squirt their information back to a single location that is our definitive current source of production. So what we decided to do was go beyond blue-green. Take the whole idea that not only are servers cattle in the new way of thinking about doing cloud things, but the whole environment is cattle. All that really matters is that we know that one of them is currently production. So let's build a new production, get it all ready to go. Then when we're happy, switch our setting of what production is over to the new one and shoot the old one in the head. Possibly not immediately. It might be useful to see if the new one really does work. Obviously, we've done all this testing, so it's going to be fine. Nothing could possibly go wrong at that point. But you never know. Maybe we want to hedge our bets a little bit. So let's think about how we can promote and demote these productions. Don't worry about whether they're called blue or green. That just means I've got more state to manage. And as we'll come on to in a minute, state is a very, very bad thing. And everything would be much easier if nobody ever remembered anything. So we need to come up with versioning. We need to come up with naming. And we spent about 3 days arguing over names. As you're all familiar, there are two really hard problems in computer science. Cache invalidation, naming, and off by one errors. We got bogged down in problem number 2. And we ended up realizing that what we actually had were these environments that were production, preview, staging for each of them, QA, acceptance test, performance test. All of a sudden we can think, hang on a minute, what we're doing here is we're building our infrastructure on AWS. We can build an exact copy of it every night, spin it up, put some artificial data through it that's 10 times what we currently cope with and see if it breaks, or see when it breaks. Take some of the uncertainty out of our scaling problems because somebody keeps on selling more of these devices. So we've got these sort of classifications of environments now, but we're going to have individual instantiations of them, and we may want to have more than one going at any one time. If you think about it for QA, we got to the point with the semi-auto-built QA environments where we had 5 of them, and we had imaginatively called them QA1, QA2, QA3, QA4, QA5. And every now and again, you'd realise all 5 were in use, and some people go and set up QA6. And but that's quite a lot of hassle because we've got to go away and do some DNS entries, which we haven't automated yet. We've got to go away and make sure that the certificate we've got is right for the SSL. We'll use a wildcard certificate, make that problem go away. And there's a certain amount of overhead that's like nobody ever bothered to automate because you only ever did it once or 5 times. So it was hard for us to then move on to spinning up another one. We had environments that didn't hang around for long. Staging would power up for long enough for us to spend a while anonymizing some data, cram it in, somebody do some tests that took about 1/10 that time, and then we'd tear it down again. So we had to improve the performance of that somewhat. And we've now got 2 production environments which we might finally be able to make look the same. So we've got these types, and we want to version the numbers, and then within those, in each of those environments, we have 1 or more hosts. For QA, I don't want to have to spin up a whole load of hosts because all I care about is the functional behaviour of the system. I want to do that on 1 medium-sized instance because I don't want to spend a fortune on it. What we also want to be able to do is to spin up the production system almost to the point of being an arbitrary shape, because we might want to migrate, say, to having a read-only replica for the MySQL, or we might want to add an additional front-end box, or we may need to start to shard out the back-ends. So we also need to come up with a host naming scheme. And then finally, we want to ensure that when we spin up all these instantiations of our environments, we don't end up accidentally using the same name and not having a clue what's going on. So actually, we came up with a very simple solution to that. Just use a Unix timestamp when you start launching an environment. Just last day, we never span up more than 1 a second. Nobody could press the button that quickly. If somebody had scripted it, I would have hurt them. Also, environment. It turns out it's a very hard word to spell. We had significant numbers of bugs caused by the fact that in some of our scripts, people could not consistently spell environment. It made me wish for the days when you had to do all of your variable definitions up at the beginning, and things would die immediately. To the point that when we started doing this in Bash, all of our Bash scripts started off with the same make Bash not behave in a completely brain-dead fashion if you see a variable you haven't seen before type stanzas, and fail early, and don't just blithely continue on just because something really important blew up at the beginning. Any of you that have written any sizable Bash will know that. This is a beautiful dream. It has one enemy, state. And state isn't a problem for QA. We just fire up a new machine. It isn't a problem for ACT test. We've already had to encapsulate all the state that we need to do acceptance testing because we're trying to do reproducible acceptance testing. However, people get really upset if every time you deploy a new version of your website, all of their data goes away and it doesn't look like they've used any electricity and we don't even know who they are anymore. So we probably need to do something about that. And by this point, we'd been running for about a year with a few thousand users. And nobody had bothered to think it would be a good idea to grandfather out the old data, archive it away. So we had 15-minute resolution meter readings that are tiny individually for thousands of devices in a single great big MySQL database. There is a whole other talk in the how on earth do you get yourself out of this hole when you've got 2 tightly coupled applications talking to the same schema being developed by 2 different development teams. Luckily, I'm not giving that talk today. That would go on for some time and involve a lot of swearing. Of course, one of the problems we'd already had to solve was, well, what happens if our main production machine, which was this physical box over here in the middle of somewhere completely different to where the rest of our system was, explodes and we lose all our data? And the answer was, well, we'll take a database backup nightly, which is great, other than the fact it now takes 5 hours to restore the database backup. Again, very, very large sets, and we did some stuff with binary backups, and that meant it only took 3 hours, which was much more acceptable. Luckily, of course, MySQL has some things that can help us with that. We had streaming replication available, and we'd already done some work to streaming replicate to a replica with the old production system. The thing that instantly occurs is, well, hang on a minute, if we already know how to replicate data to a replica, why don't we just treat the new environment we're creating as a replica for the old one? And then we can build that thing when we like. We can synchronize the data up, and we can even have reasonable confidence we haven't lost anything because we've got ways of checking that we're at the same point in the MySQL logs. And we've got a vaguely manageable way now of stopping and starting the old and the new environments. So we're starting to build up a set of tools which mean that we can actually do this. There was one other horrible bit of state which we had, which was that we were generating cached images for the website so that people could see what the graphs of their energy usage were, and we could give them prizes when they did really well and when they saved lots of carbon. I suspect we probably used more carbon in CPU cycles generating the images than they'd save, but shh, don't tell anyone. These again had accumulated and again were very hard to regenerate due to the way that they'd been accumulated, and they were dependent on the time at which they had been generated, and if you tried to rebuild them, the database state had changed and they wouldn't look the same as they did before. And therefore the canonical source of these images, if you needed to go and display them to people, was the version that happened to have been generated at 3 in the morning on a Monday. And therefore we needed to replicate those as well. We never did, in the time that I was there, really crack that problem, other than just r-syncing them around, which is fine other than the fact that there were hundreds of thousands of them in one directory. The correct answer there almost certainly was, well, we've started paying all this money to AWS, why don't we just shove them in S3 and then have an embedded URL that points at S3, and then they can worry about replicating them, because apparently they're not too bad at that sort of thing. And we had logs to ship around as well. Because it turns out that sometimes the devices in the field misbehaved a bit, and they acted in ways that nobody believed was possible. Because it turns out that not all people's houses are the same, not all people's electricity meters are the same, and quite often there are big differences in the way that people have their houses arranged. We'd get signal problems, we'd get people with electricity meters outside, which meant the batteries degraded very quickly because it was cold in the winter, and things beyond the reckoning of possibility that could possibly have happened. In particular, when we did a gas version of the meter reader itself, which clipped onto your gas meter and watched the disk go round or watched for a flashing light. Most people's gas meters aren't in their houses anymore. They're often buried deep in concrete holes, several meters away from the property line, and the radio transmission quality of concrete is not ideal for this application. So we would get some very funny behavior at the edge of radio range. And it also turned out that we would get bugs in the firmware because the firmware was not being continuously integrated, it was being manually tested. And every time a new release came out, we would see in the release notes from the third party that was developing it that all the bugs had been fixed. And this made me very happy, and then I would be continually disappointed. Which meant that because those devices are off in people's houses all over the place, behaving in weird ways, it was the server-side logs that were really important for us to improve the product. And therefore we had to persist them. I couldn't just throw them away when I flattened the environment and brought up a new one. So again, putting in things like syslog to do replication of the logs across machines, and then streaming replicating those back onto the new environment that was coming up, and deciding how much we cared about retaining them for long periods of time. In general, we'd keep them for a couple of releases, which by this point we'd got to doing 2-week releases rather than the original release, panic when it didn't work, fix it on the box, then go away and try and rewrite it, take 6 months to do it, then try and do that release that you've just rewritten, realise you can't merge it into the existing code because you've gone in a different direction and you're bringing all these different repositories together, and it doesn't work anyway. So we've made a few improvements on that side. Which brings me again to another exciting problem we had, which was that we had some quite bad fragmentation. I mostly chose this picture not because it has anything to do with the title, but because I really liked the idea of an aeroplane with a bar fitted to the wings. And I didn't have anywhere else to use it, so it got picked for this slide. I particularly like the careful balancing that they've done, where they've got one person or 2 people out on one wing at the top and an entire bar down on the other side. I can only imagine that they have to be careful about the rate at which people drink. Sort of irrelevant, but a fun picture all the same. We had 6 Git repositories for this application. One of them, as I mentioned earlier on, was a Git clone via Git SVN of a third-party Subversion repository. we had interconnections like you wouldn't believe, and we had versioned dependencies across multiple repositories. Just doesn't work. When what we're trying to do is to say that we want a single way of reproducing our build. We do not want to have to worry that we check in some code into one of our 6 repositories, and we have to very quickly check some code into another one because they interrelate and they depend on each other, because we've gone and tightly coupled our application together via our database. So, and this took some time. We went through a long period where, first of all, we'd written a lot of the operations scripts that drove the Jenkins side off on their own. We pulled those into the repository. We'd written some scripts that deployed the load balancer, what we called the relay front end, in a different repository. We pulled that into the main repository. And over time, we got to the point where actually we only had 2 left. This third-party SVN, Git, in it goes, and the main hunk of the loop application, which we'd finally got into a place where it meant that actually we could make atomic changes to our application, and we could consistently go forwards without having to worry about timing issues. Since I've left, they've actually now managed to do away with the subversion, get the third parties working in Git, and merge the final bit of it all together. So they now have one repository, apart from the fact the firmware's off in a different one. But at least that doesn't change very often, and we can snapshot and version that and merge it in. It isn't as tightly coupled to the rest of the application as all the bits that join together via a database. So one of the things we learned from that is do not spread your code out across multiple repositories unless you really, really have to. Just because it feels like these are logical blocks that should fit somewhere else, think more about how they interrelate and how they change. And that includes your ops code as well as your development code, if at all possible. The two often end up much, much more tightly coupled than you would think. This also brings me on to another thing that ends up tightly coupled to your infrastructure. Oh, that's a shame. It doesn't come out very well. What we have here is a butler who appears to be about to attack someone with a bottle while somebody else has disguised themselves as a standing lamp. I felt this was, having explained it, it sounds utterly ludicrous. But then so does Jenkins at times, so that probably fits reasonably well. I quite like Jenkins, but only quite like it. Considering that its main function is to allow you to do scripted, reproducible builds and automation, it is one of the least automatable bits of software I've ever come across. And in particular, if you're not really careful with it, you find that you've built a whole load of logic and a whole load of code into Jenkins in a way that decouples it from your application again. So building smarts into Jenkins so that it knows how to deploy this machine or build that set of acceptance tests means that when you want to actually change how that works, you're back into this horrible race again where we're changing the repository, we're changing Jenkins, we're either doing it in a way that means that both work but not quite, and then we have to grandfather out old code, or it's just going to break the build because we've purposefully broken the way the build works and we need to make some changes rapidly. What we ended up doing was saying, thou shalt not. Each Jenkins job has responsibility for setting up some environment, some passwords, knowledge about what it is we're actually building, and running a single entry point script which lives in the repository. And that must do everything. It can call whatever it likes underneath. It can be as complicated as you like, but we had a single bash script with a standard name that was the entry point for each of our Jenkins jobs. All the way through from build QA, build act test, to the various bits that we needed to do to promote and deploy our new production environments. Because it turns out the best way to use Jenkins is to use it as minimally as you can get away with and just enjoy the fact it gives you pretty pictures and blue and green flashing lights and things. So where this got us to is that this was a fairly good model for how we were building our production system originally, with just as much health and safety awareness, but possibly a little taller. And certainly we had pickaxes. But all of a sudden, actually it wasn't that difficult anymore. Building a production environment was just as easy as building a QA environment, and actually we didn't really care how it happened anymore because we'd written the scripts once that meant we knew how it happened, and we could just keep building them. The first one of these that we had to sort of do in anger was a special case deployment, in that it was deploying the new production and the new preview environment. So we still had this old environment busy chunking along with a few devices connected to it that was like our canary. So we did that, went fairly straightforwardly. Took about 2 or 3 weeks longer than we thought it was going to, which was fine because we'd allowed 2 weeks after doing the preview migration to get all the bugs sorted out so that we could do a production one. Instead, we waited 1.5 days. Because it turns out that we were just building the same thing again. There were a couple of minor special cases because we were sucking data from a third-party machine that didn't have all our AWS security group awareness and all the rest of it. But barring 1 or 2 very small special cases, which we'd actually been testing, because what we could do is we could keep on building a new production environment and then throwing it away without ever actually promoting it to being a real one. So we did the preview and the production deployment dozens of times before we did it for real, and we knew it backwards. We did the production switchover at 11 a.m. on a Friday. We were in the pub at 12. It all just worked. And we knew it was all just going to work because we'd already failed at doing it 10, 15 times. All of a sudden, we can do everything. Nothing really is a surprise. Well, nearly nothing. For this particular case, we'd purposefully chosen to have essentially a code freeze for an entire iteration, and all we'd done is work on the ops side. We knew that there was nothing new coming through in the code base that could upset the apple cart. Of course, once we actually start getting code changes through, it turns out that what works for 5 devices didn't always work for 2,000. But we'll come on to that in a moment. So what does our release lifecycle look like? Blurry, apparently. That was a poor choice of colour, Stu. Next time, always just do everything in black and white. So you might be able to read that, you might not. The beginning, we have the commit. Somebody actually bothers to check some code in. And we were probably seeing 4 to 5 major commits a day on a dev team that consisted of 2 people and a senior, 2 juniors and a senior. In addition to that, there was a team that essentially added up to about 3 full-time staff, but was spread across a larger group of people with the third party who were doing things at about the same sort of rate. And of course, Muggins here, occasionally shouting at people for breaking the beautiful system that he'd worked so hard to build. Every commit would trigger a build. The build ran some basic unit tests, very basic, almost non-existent, because no unit testing had been done whilst the application was being written originally. The only unit tests we had were in the bits of code that had been written since then, when the new lead dev had come in and gone, my God, you've got no unit tests, I can't refactor anything. Turns out you can get away with it if you wrap a lot of acceptance tests around what you've got, and you expect it to fail all the time, and so therefore you build your systems to fail all the time. This gives us a build artifact which we can stick in a repository somewhere. We ended up sticking them just in S3, just somewhere that we can pull from the web. That equally well could just be a directory on your build server, and to the point that Jenkins can do artifact management and that sort of thing for you. Don't let Jenkins do anything. We trigger an acceptance test. In practice, our acceptance tests were taking 1 to 2 hours to run in their entirety. And quite often people would check in multiple times in that time. So all we ever did was make sure that the most recent build that we had been acceptance tested. We didn't worry too much about the intermediates. We also therefore then at that point had the ability to manually spin up an environment which exactly looked like acceptance test so that people could manually step through them and therefore have a perfect environment for testing in. And they could also spin up these in order to do manual checks that features had been implemented correctly and that sort of thing. This would go on for a fortnight. People would keep working. Towards the end of our fortnightly iterations, we would spin up, first of all, a preview staging. The advantage of getting these 2 stagings spun up early was if people had been, I'm going to use the phrase, I think dicking about is the best phrase to use, with the deployment scripts, particularly the deployment scripts that were more interested in moving data around, that horrible state stuff. We couldn't really test that on the early parts of the system because we didn't have any of that state in QA. The first place we'd start to see that replication and all the rest of it happening was when we get to the staging environments. We actually got to the point where we introduced a third staging environment called test staging, which purely existed to test that we could still deploy staging. And we ran that every night because it was we were getting releases delayed because we were finding that something had happened in the deployment script which only affected the late part of the release cycle when we actually wanted to get the release out the door. We can roll up these preview and production stagings. This gives us anonymized real data to work with. That means that the final level of sort of QA testing can happen. That was still generally manual. And we then generally proceed down the preview line before we proceeded down the production line, on the grounds that if we annoyed the 25 people that mostly either worked for us or worked for, or were friends and family of people that worked for us, we could just go, oh, sorry about that, it'll all be fine, don't worry. And we would walk down there, we would deploy a new preview environment, which we would call the secondary. It would initially just be essentially completely quiesced, there was no code executing, but the MySQL was busy there, rapidly running to catch up with the previous release. We would then detach that and also put our load balancer into maintenance mode. So at that point, we're not getting any more data from the devices. People are just getting the site is down. We could then run our upgrade process, which would make any schema changes that needed to be made. Remember, again, because we've got this tight coupling, the schema ends up being very important as a way of communicating between the front and the back end, and it's really, really hard to change because you need to coordinate that. We start it up. At this point, it's running, but the load balancer is still off. However, we can go and look at it directly and make sure it looks okay. So this gave us a final go, no-go point. And this proved to be useful on many occasions in that we realized that at one point, for example, the SSL certificates had wandered off in a random direction for some reason that we didn't fully understand. And we caught that before we even went live. And then what we did, having determined that actually this was a dud release, we just switched the old one back on again and pointed the load balancer at it. And, oh, look, the release didn't happen. But we didn't lose any data because the devices are all just patiently waiting to make their reconnection and spooling whatever they've got. And the users are going, oh, the site is down. One of the advantages, again, of our application was that the user base typically used it either early in the morning before they went to work or late in the evening when they got home, which meant our prime release window was between 10 a.m. and 4 p.m. Always look for jobs like that. So we could just go back and say, well, actually, we're going to promote the old primary back to being the first one. Assuming that hadn't happened and everything was happy and smiley, we could retire the old one, switch the machines off, maybe keep the disk images around for a while, just in case we wanted to go and have a poke, and then eventually delete them and stop paying AWS for the privilege of storing that data. And then we would do exactly the same thing again, but this time for production. But having done this and got it out the door and enjoyed our trip to the pub and come back to find it was still working, I think by that point we'd had sufficient beer, we were relaxed about that. It wouldn't really have mattered, it's only Friday afternoon. Who's bothered about checking how much electricity you're using on a Friday afternoon? We realised that we still had a lot of unpleasantry that we'd sort of masked and hidden and coped with because we knew that we could always just go back to where we were before. The setting up the databases was extremely slow. We were doing a database dump with the MySQL log position magic in it and then restoring that onto the new secondary we were trying to prepare. That was very, very slow because essentially you're doing a full restore. And then somebody had the bright idea, hang on a minute, we're doing replication. Why don't we just replicate? And we switched that over so that it just did streaming replication from zero, essentially. We reset the log positions on one release, and then from that point onwards, each extra release started by reliving a database restore that we'd done several months before, essentially, by that point, and then running like crazy to introduce all the data that had gone on the top. And that took about a third the time that dumping and restoring did, until it broke. And then we had to work out why we were getting clashes. And then we realised it was because we'd left a bit of the application running that we hadn't realised was running, and it was busy making schema changes whilst we were trying to do the streaming replication. But that's all right because we were just a secondary, so we can blow it away and rebuild it. And it's exactly, and now it's got the fix in. It's all great. We also had this horrible old snapshot that somebody had created a year before that whilst nobody knew what was in it, at least it was much smaller, nobody knew what was in it. And people keep on finding security problems with software. I can't understand why people bother to look for security problems. It seems like such a waste of time. In the time that we were doing this, somebody found out that SSL doesn't really live up to secure. Somebody found out that Bash can pretty much do whatever it likes and hang the consequences. And then somebody found out that SSL was still not very secure. The Bash one in particular was a problem because whilst we were dealing with OpenSSL as a dependency of the installation process, Bash just came along with the base image. So what we did was we decided that initially we would update those snapshots and we would therefore need to version the snapshot that we were using. So all of a sudden, our entire operating system is now versioned within the repository, so it's all reproducible. We were also paying an extra whatever it is in AWS for Red Hat Enterprise Linux, whilst making full use of all the support that we were getting, obviously. And we were doing it with this ludicrous snapshot method, which was just what had been done in a hurry. So instead, we did the work to move over to CentOS AMIs. And what that meant was we introduced some code into the repository that says from this point on, when you build your base environments, you build them, pardon me, as CentOS AMIs. If we need to go back to the old way of doing it, just check out that old version of the code, and there it is. And we can test that, and we can be confident that we're not going to find anything unusual and weird when we get to do the release. And then the final big thing that we managed to do was we took all of those clever build scripts and then took out all the AWS-specific bits, replaced it with Vagrant-specific bits, and now people could build the entire stack on their laptop. And proved to be very, very easy because actually it was only a little bit of the work at the beginning that needed to be changed. The other thing it meant we could do was we could version the size of the instance we were using. It lived within the repository. Oh no, we think we're going to hit the end of our scaling limits. Change the configuration file in the repository that says what our production instance size is. Redeploy. Oh look, we've got twice as many CPUs, twice as much RAM as we did before. Need a MySQL replica? Check it in. Next time you build your infrastructure, it's a new infrastructure and it's going through the same tests. There are no surprises happening. Do we need to shard our application? This particular application, because it consists of data coming in from a device that's looked at by one person, is extremely shardable. All shards are really a special case of our environments. Just launch 5 of them. And then we need to make our load balancer a bit smarter so that it knows to send individuals to different ones. Dead easy. Maybe. This led us to pretty much the point at which I decided that my work here was done. And that if I hung around, I was only going to have to start fixing my own code. And nobody wants to be in that situation. But it did teach me and the people I was working with some very useful lessons. First of all, version control everything and try and do it in one place. The more repositories you have, the more interrelations you have between your code base. If you can possibly have one true version of it, go with that. Special case environments are very, very painful. Make everything as consistent as you possibly can. Because then you can do things like create a vagrant dev image just by changing one bit of code. Never ever write more than 5 lines of bash. We wrote as close as you could possibly get to well-structured bash, and it still gives me nightmares. Because we had some existing shell scripts that did some of the machine spin-up for us, we decided to just keep going in that way rather than rewriting from scratch. We would have been much more sensible throwing the whole lot away, just using some bash stubs to set environments and that sort of thing, and then, say, calling Python code or something like that, especially as Python has a reasonably good AWS integration layer in the shape of Boto. Fail as early as you possibly can, and always look to bring that failure forwards. The sooner you fail, the sooner you can fix things, and the less stupid you look, to a certain degree. The cloud is great. It allows you to think about how you build your infrastructures in a completely different way to if you're actually buying physical hardware. But it also is a great way to spend money. At various points we thought, it would be really useful to keep QA environments around, because then we can go back and look at them. I showed you about acceptance tests. So we can see we had a bad acceptance test run. We want to know what went wrong. The easy way to do that was just to spin the environment back up and then reproduce what had gone wrong, which was great until we realized that we were using 100 terabytes of storage. Luckily, we realized quickly enough that we could get it back under control before we got too far into the billing cycle. And it's very easy to end up just, if you're automatically spinning machines up, it's very easy to automatically spin a lot of machines up. And AWS, Amazon are delighted if you do that because they have a billing system. And that pretty much brings me to the end of the journey. So, any questions? Yep, we've got one.
If you have the opportunity to not take the job, would you go back and take the job or not?
Probably not, to be fair. There were other, but not for the reasons that were to do with this. This is one of the nicest infrastructure projects I've ever worked on. The company itself had other problems, so some of which I have alluded to in terms of resourcing and in terms of structure and in terms of their approach to projects. Essentially, we managed to clobber them into doing this one right. Okay, any more? Excellent, I can sit down. Thanks very much.